Titration curves are one of the most confusing topics in general chemistry, but unfortunately they are high yield on the MCAT and in your general chemistry classes. In this video, I'm going to explain the titration curve of alanine in a simple to understand way. I'm going to walk you through the process of drawing out the curve and point out key points that you're typically tested on the MCAT or in your general chemistry class. So first of all, let's talk about the different forms that you can have when it comes to alanine in terms of its protonation state. You have three different forms. Form number one is where the amino and carboxylic acid group are both protonated, in which case you carry an overall positive charge. This occurs at very low pHs. So next you have a zwitterion where you deprotonate the carboxylic acid, but your amino group is still protonated. This is as you're increasing that pH. Finally, once you reach really high pHs, you get this overall negatively charged alanine molecule where both the amino and carboxyl group have been deprotonated. So the idea behind the titration curve is that you get a weak acid, in this case our amino acid over here, and you continuously add a strong base to raise the pH of your solution. And that's exactly what we're going to do over here. So you start to add your base, and then at some point around like about 2.5, maybe a little more than 2.5, what happens is you start to see a plateau in the curve. Now, why do you see this plateau? Because you've hit your pKa1 value. What's that? Let me explain. So as you can see right here, pKa1 specifically deals with the carboxylic acid group in alanine. So right here, I've drawn out the carboxylic acid group. Really, it represents the entire amino acid, but since the amino group is not being impacted at this point, I didn't draw it out. So I just drew out the carboxylic acid group. The idea here is that when you hit your pKa1 value, what's going to happen is half of your solution will be in the deprotonated form, so the conjugate base form, and the other half will be in the acid form, in the protonated carboxylic acid. And at that point, you reach your pKa1 value. We also call this the buffer region, the first buffer region. When we say buffer region, it's essentially reflecting the idea that despite you adding more NaOH equivalents over here, you're not really increasing your pH. And that's because, as we know, buffer regions tend to be resistant to changes in pH, and that's because any base that you add over here is just going to deprotonate the acid, and it's not really going to impact the overall pH of the solution. So we call this pKa1. We can call it the buffer region. The buffer region is more the entire region over here. And we can also call it the midpoint. All right, quick MCAT tie-in over here. If they ask you about midpoint 1, you should know that that occurs at the pH which is equal to pKa1. And so therefore, if they ask you what types or what forms of alanine exist in the solution, then you say the form that is fully protonated and the form that exists in a zwitterion. All right, now let's continue with drawing out our curve. Now we continue to add our strong base, and at some point we escape that buffer region. And you'll notice that at a particular point, you have this steep rise in the curve. Why is this occurring? This is because at this point specifically, right about here, you've hit your equivalence point. As you can see right here, you've added one equivalent of NaOH. In other words, you have fully deprotonated your entire sample. You've fully deprotonated all of the carboxylic acid groups in your solution. So at this point, your entire solution consists of form number 2, the zwitterion. And we have a very specific name for the pH value at which we hit the zwitterion, and that is your PI, or your isoelectric point. And indeed, the isoelectric point of alanine is about 6.1. So this is your PI value. We also call it the equivalence point. So quick MCAT tie-in, they can either ask you, like, at the equivalence point, which form of the amino acid exists? Well, you know it's the zwitterion form. They can also ask you at which point on the titration curve do you hit the PI value of an amino acid? Well, if it's a neutral amino acid, then it's the first equivalence point. Okay, so at this point, all our sample is in this form, and that's because we're at a high enough pH where we've deprotonated all the carboxylic acids in our solution, but we haven't really deprotonated the amino group to any meaningful extent. But now, as we continue to add more equivalents of OH, we will eventually start to deprotonate the amino group. Because although technically an amino group is a base, if you really substantially raise the pH of the surrounding environment, then at that point, the weak base over here will start to act as an acid relative to the surrounding environment, thus donating hydrogen atoms to it. So what you'll see over here, as you increase the pH to about 10, maybe even a little less, like 9.8, 9.9, you will start to see that once again you hit a plateau over here. And this is because, as you may have predicted at this point, we've hit our pKa2. What's our pKa2? Well, it's the pKa of the amino group over here, pKa2. So at this point, what forms of the amino acid do we have in solution? We have forms 2 and 3. So the zwitterion and the one that carries an overall negative charge. And importantly, at the pKa value, they exist in equal concentrations. This is a very important MCAT tie-in. They can ask you, what's the relative concentration at the pKa value? Whenever they ask you about the pKa value, you should know that the conjugate base and its acid exist in equal concentrations. Okay, so let me just erase this over here. We can also call this point midpoint 2. Okay, as we continue to add more of our strong base over here, you will see that once again you'll hit that steep incline as we saw over here. And at this point, as you may have predicted, what happened was you hit your second equivalence point. And at this point, not very high yield on the MCAT, but the idea is that you have fully deprotonated your entire amino group sample. So now the entire amino acid solution is consistent of this form, where both the amino group and the carboxylic acid group are deprotonated. So let's do a quick recap of the important points. Midpoint 1 is where you hit pKa1, the pKa of the carboxylic acid group. At this point, you'll have equal concentrations of form 1 and 2 over here. And then at the equivalence point, which is the pi value, your entire solution will be consistent of this form only. And then as you continue to increase the pH, you'll hit midpoint 2, which is your pKa2 value, where you will have equal concentrations of form 2 and form 3. And then finally, once you hit the second equivalence point over here, your entire solution will contain only this form of the amino acid. If you found this video helpful, like and subscribe, and share it with any of your friends who may be studying for the MCAT or taking general chemistry. It really helps the channel grow, and I would really appreciate it. If you're wondering why my voice was a bit off, it's because I'm recovering from a cold. See you in the next one.